My name is Steven, and I am an AP Chemistry tutor at Academic Magnet High School, and in this video I'll be going over how to determine whether dissolutions are endo or exothermic. Suppose we have two samples, one of water, H2O, and one of an ionic compound, NaCl or sodium chloride. Before the reaction, our water and ionic compound, in this case sodium chloride or NaCl, are separate. The water, because of oxygen's strong electronegativity, forms a very polar bond with its hydrogens, creating a partial negative dipole on the oxygen and two partial positive dipoles on each of the hydrogens. These dipoles are attracted to their opposites on the other water molecules, and this creates hydrogen bonds. In our ionic compound, the electron has been stripped from sodium and is transferred to chlorine, giving sodium a +1 charge and chlorine a -1 charge. These atoms are attracted to one another by electromagnetism, forming a tight 1-to-1 ratio lattice of chlorine and sodium ions. Remember for later that larger positive and negative ionic charges and smaller atomic radii can increase the strength of these ionic bonds, as larger charges are more forcefully attracted to one another at shorter distances according to Coulomb's law. When NaCl is dissolved in water, the polarity of the water molecules causes the constituent ions of the crystal lattice to split apart and become free-floating ions in solution. Due to their relatively large whole number charges, as opposed to the partial dipoles of water molecules, an attraction is formed between the negative dipoles of the water molecules and the cation, and between the positive dipoles of the water molecule and the anion. These are called ion dipole forces and are another type of intermolecular forces. Remember, forming bonds or forming stronger bonds releases energy or is exothermic, whereas breaking bonds or forming weaker bonds takes in energy and is endothermic. So in order to determine whether the dissolution of our salt is endo or exothermic, we need to determine which of these forces are stronger. Stronger forces can be predicted using the ionic bonding rules from earlier, but in order to see if a salt is really endo or exothermic, we need data. So, in this sample practice problem, we're given that when 29.22 grams of NaCl with a molar mass of 58.44 grams per mole are added to 100 milliliters of water at 25 degrees Celsius, the temperature of the solution increases to 28.61 degrees Celsius. We're asked to find the enthalpy of dissolution of NaCl given that the specific heat of the resulting solution is 4.18 joules per gram degrees Celsius. First, consider the number of moles of NaCl being added. 29.22 grams divided by 58.44 grams per mole gives us 0.5 moles of NaCl. Now we must consider the energy change of the surroundings, or the solution. This is given to us by energy equals the mass of the solution times the specific heat of the solution times the change in temperature of the solution. Expanding, we can plug in our values and determine that since the temperature increased 3.61 degrees Celsius, that 1.95 kilojoules of energy was delivered into the solution from the NaCl dissolving. So now that we know our dissolution of NaCl is exothermic, as it released water into the solution, released energy into the solution, heating up the water. But how exothermic is it? For this, we need to find the enthalpy of dissolution, or the energy change when the NaCl is dissolved. Delta H, or the enthalpy of dissolution, can be found by dividing the number of kilojoules released in the dissolution by the number of moles of substance dissolved, to yield a result in kilojoules per mole of substance. Dividing our values, we can come to the solution that the enthalpy of dissolution of NaCl is negative 3.90 kilojoules per mole, as 3.90 kilojoules of energy are released or lost by NaCl per mole of NaCl dissolved. Thank you for watching, and I hope this helped you prepare for your upcoming AP exam. Thank you to Leah Bagg for suggesting this topic for a video.